All right, so my name is Pablo Caif, and I'm going to talk to you about geospatial queries. So what the idea of this is basically access to map data stored in geospatial databases, and we can run queries and get all the associated data. And just going to give you a few hints. I'm from Shine Technologies. Shine Technologies is a digital consultancy based here in Melbourne. We work with large enterprises to build digital products. We are passionate about delivering business value, and we're always looking for good Java developers that are also passionate about delivering good stuff. So if someone is interested, can talk to me. So if I'm talking, you might be asking, we're talking about accessing data in maps and stuff like that. Why don't you use Google Maps? Google Maps offers a pretty good API. You can do geocoding, which is, you can get from an address to a specific point, from a point to an address, to in the reverse. You can also do certain operations with polygons, like find the intersection, find a point, for example, and what's the suburb where the point belongs to. You can also extract that information, so you can get, all the businesses around that a specific suburb, can get the state name. But what happens when what we got stored in this, the map that we need to access, is not actually in Google Maps? So there could be several cases. Like, for example, the data from the ABS, the Australian Bureau of Statistics, all the sense information, if it's distributed by areas, stuff like, for example, average income from for specific suburbs, or average age, or stuff like, for example, for councils, if they have a map data for their power grid or their irrigation system. So we could freak out, like this poor guy here. We can use Geotools. And what is Geotools? So Geotools is an open source implementation of the Geospatial Consortium. It's basically a set of libraries that allow you to access all this map data. It defines a layer of abstraction of the spatial concepts that makes everything much easier to access and to play with. It also simplifies the access to the Java topology suite. The Java topology suite geometry, basically, it's a set of libraries that allows you to operate with polygons, do all the sort of geometric operations, like finding polygons that surround a specific polygon and several other things. It provides attributes and spatial filtering, so you can actually get a specific polygon using some sort of criteria, like, for example, the suburb name. You might get a set of polygons depending how the map is being stored. And finally, it provides different decoding technologies for different databases. So you can actually there are a set of different formats, and you can access to them. Why would you use it? So first thing is there are a set of different geospatial coordinate systems. So we got decimal coordinates in degree, geodetic coordinates. There are also different geospatial database formats. So we got the formats, for example, you can put in your GPS, formats used by the ABS, or the format used by OpenStreetMaps. And finally, the polygons arithmetic is really complex. So if we want to, do operations like find the polygon that contains a specific point, if we wanted to implement that, there would be a lot of work, prone to errors. and it solves that problem for us. And all this information, so a particular aspect of Geotools is that it can access to geospatial databases. So the geospatial databases basically store polygons and their associated metadata. This is all the different geometries that form part of the map are stored, and you can also get the metadata like area in square meters or in any measure, name, or whatever you want to store associated with it. As I mentioned before, Geotools supports different formats for databases, and it also includes a JDBC interface, so you can access to geospatial databases stored in relational databases like Oracle or MySQL. So what is actually in the geospatial databases? So as I said, you have the maps is normally composed of a set of polygons or geometries. That's stored in a form of vectors in a numeric form. You also have here the features, which are all the attributes that you might want to associate to the map. Features could be, as I said a moment ago, like, for example, area, suburb name, anything you want to store, and mainly the relationship between the two of them. So in order to access to this geospatial data stored in geospatial databases, we can use the SQL queries. SQL stands for Common Query Language. It allows you to write simple expressions to solve complex polygon operations. So if we want intersect two polygons or find areas that are adjacent to another areas, we can just write a query. They allow to filter polygons that match with a specific criteria. And yeah, last thing is going to be a very short demo. So bear with me. So what I have here is basically I downloaded a set of a shapefile, which is a geospatial database. You can see it over there. This is basically a set of files. This is from the Australian Bureau of Statistics. It's from the census information. So they basically divide the areas in specific areas. So you can go from SA1 is the smaller area, and they go SA2 and SA3. And they store a lot of associated information like average income, average age, and stuff like that. And this is a very simple Gradle project. So let me show you. It's a bit difficult to screen, but there you go. So basically, I'm just adding 3 libraries in there, 3 jars. And what I'm going to do is just going to quickly show you how to connect to a geospatial database. Can you see from behind? This looks good. All right. So first thing we're going to do is actually open the main file of the shape data file, which is this one. Basically, we can have this data store, which is the fiddle file data store, and we basically just pass the file URL. And the other thing we have is the feature source. Feature source is kind of like the connection to a database, so you can actually run the queries on it. Just gonna also put the constructor in order to call this code, right? So what I'm doing there basically is just initializing the calling these 2 methods that I created there. The good thing about Geotools is it comes with a whole set of graphic libraries. So you can also actually write Swing application and access to it. So I actually took advantage of that. So see if I can run. So this should be enough to load the actual map. So this is the actual geospatial database. These are all the vectors and all the polygons in Victoria. And so I didn't write this. This is basically all part of Geotools. But you can actually select a specific polygon. And retrieve the associated information. So that's what I was talking about in terms of the features. So you get the names they assign to different regions and a measure of area in a specific in a normalized way. So what I want to do is add a few buttons in here. We're going to write a few queries. I'm going to show you how to write the queries and I'm going to be adding buttons in there. So first thing we're going to write, it's a query that is going to allow us to access, just going to move that up, to access to all the polygons where the name is Melbourne. This is going to effectively get all the polygons in the CBD area. Going to put there. So that's how you build a query. So there is this filter class. It's actually an interface. And you create a query and specify the SA1 name. This is one of the attributes that you saw a moment ago. Just specify Melbourne. And then just to get features on the feature source, which was the one that we initialized before. And we get basically just a collection. So I got another method there to just display the results in the console. And you can see the access is pretty similar to JDBC when you're reading a record set. It's basically to feature the get attribute and pass the attribute name. So this effectively is giving me all the polygons matching that criteria. Of course, we also need to add our code in there. So this is all Swing stuff. The way that is connected, there is no Spring or anything. It's just a very simple, basic application. The purpose is just to demo how we can run the queries. So I'm going to put there the button. It's basically just a button that says query by suburb. And here's the important bit. Just I got an instance, a reference to that Geotools queries class that you see there. And I'm calling the method find features by suburb. So if we run that, you can see the button there. Just going to zoom in into the CBD area so you can actually see the results once we run. So you can actually see, that's all the polygons matching with that query. And also, if we go and see here, this is my console, very primitive console login. So you can see all the polygons that match with that. This is because, as I said before, this ABS data, so it's basically a subdivision of what you would normally consider a suburb or anything like that, right? So, oops, no, I didn't want to kill that one. Sorry. All right. So the next one we're going to write is the features by in a specific area. So this is basically, we're going to filter using different criteria. Just let's go back to our class in here. So again, we can actually use comparators, this kind of operators. So this is where the area is greater than 14 billion. It's a normalized measure. So we also need to add, of course, the actual pattern. So if we run now, run the queries, and we see the two big areas over there. It's actually three. There are actually three. Two of them are adjacent. Right. So another one we're going to do is feature by point. So in this case, is going a little bit deeper. So we want to get a polygon that contains a specific point in coordinates in lat long. Go back to this class. Just going to add it around there. So it has a little bit of a fancy syntax. So you basically specify, we got this operator which is contains. The geom actually stands for the geometry. And you pass the geometry and then you pass the actual point. Something that got me at the beginning was you don't need to specify the comma here. And the coordinates are inverted, so it's long lat. So that's going to also need to add my button here. So those are the coordinates of Wilson's prime. So if I run the query, that polygon should get marked. There you go. You can see the actual results there. And the last one I'm going to write is actually an area of the map. Let's see if I can find the. So you can actually define a bounding box and find all the polygons that are in that bounding box, and you need to define the minimum point and the maximum point in there. This is in coordinates. So we're going to run a query that's going to return all the polygons in Bentley East. Okay, so we go back again to our queries. Just going to add it there. Wrong method. Sorry. Okay, so this is what I was talking about. So you got this operator bounding a B box. Again, you pass the geometry, first point and second point. So first point is the minimum point that I was talking about. Maximum point is the other point you put there. And last thing would be our button there. So it's going to zoom in a little bit so we can actually get to see the area when it gets marked. So last one there. There you go. And we can see here all the actual polygons.
So that's not entirely square. Like if you zoom in a bit.
No, because it's basically just the polygons. So it might not be square, exactly square. It's all the polygons inside that are inside the bounding box.
Yeah.
So that actually, part of that one. Yeah.
The ones that are inside, like half in, do they get?
They're also considered, yes.
Yeah.
Yes. So that's basically it. Of course, it has a lot of other things, Geotools, but the focus here is, the geospatial queries. So, any question?
So you showed the bounding box
Mm-hmm.
special word before. Presumably there's like polygon shapes that you can put in there, or is it, what other keywords are there for polygon?
Yes, it has a lot of, the syntax is pretty complex. So you're talking about this, this in here, right? Yes, you can define all the different, operations like intersect and stuff like that. Actually, if you go to the, see if I can give to you the link to the Geotools. There are a few examples of other queries. Yeah, you can do a lot of different operators.
Yeah, you can. You've got the internet. There's a Queen's called Div Wi-Fi that's open. You can go into it. Or you can take the next question.
Yeah, I think it's gonna be easier.
Yeah.
Yeah, I don't think I'm gonna find it right now. Yeah.
And the data files you are reading, these ABS data files, are these in a particular, is there a particular standard format for these, or?
Yeah, so these are in the shapefile format. So that's why they have that extension SHP. And the main file you actually try to open is the SHP. It's the shapefile database format is basically a set of files. That's what you see in several files there. So once you open this one, it reads data from all the rest of the files.
Is it like a industry-wide format, or is it just format ABS users?
It's an industrialized format, and also the ABS use it. But I think I know that some GPS use different formats, and that's the good thing. You can access to these different formats. And basically, you need to put it in a database. It has pretty good performance.
So, sorry.
With the formats, I suppose this I think follows on to that. But could you use this for converting between formats? Like if I had a polar coordinate data set and wanted to get it into Mercator format?
So I haven't dig too deep into that.
Yeah.
I think what I think I saw when I was reading the documentation is, since it's all normalized, it will actually accept the different formats depending on what you pass in here.
Yep. But then convert them all to its own.
Yeah, it does all for you. Yeah.
What's the performance like? Like how many polygons can you have in your shapefile? So for Victoria, do you know how many polygons are in there roughly, and could you do the whole of Australia to that same?
Yes. So we've used in a project we used the whole Australia, and I can't remember how many there were. I think it was in terms of 40. I think it was 45K, 45,000 around that, and accessing or getting. So one of the queries we're doing is actually this one there, and that takes I think it's around 20 to 30 milliseconds to get the actual polygon. So it's pretty quick. It has sort of like a start period, so it needs to get ready. But then after that, it starts getting results pretty quick.
And how long does it take to start that start period? How long does
That sort of warm up. Yeah, it's so the first queries you run might take 200 milliseconds, maybe 400 milliseconds, and then after you keep running queries, they start getting lower and lower.
And can you do like in SQL? Can you have joins those two, find those two filters together? Can I do something like that where it makes sense to do so?
Yeah, I haven't looked into that. I don't know. Might be possible.